Hello, I'm Nick from the Cosmosphere in Hutchinson, Kansas. Next to me is a model of the Space Shuttle stack, including the orbiter, which carried the crew, the two solid rocket boosters, or SRBs, and the orange external tank. Now, in our video about solid versus liquid fuels, we discussed the pros and cons of each. The Space Shuttle incorporated both, using them for the best of both worlds. It used the immense power of the SRBs to lift itself off the launch pad. And then, once it had gotten through the thickest part of Earth's atmosphere and gained enough inertia, the SRBs were dropped, and it used the incredible efficiency of liquid fuel from its three main engines to get into orbit. Now, one of the cons about liquid fuel is its storage, and here to talk to us about the external tank and the importance of insulation is astronaut Don Thomas.
Hi, I'm NASA astronaut Don Thomas, and I had the amazing opportunity to fly on 4 Space Shuttle missions. 3 of those were on board Space Shuttle Columbia, and 1 was aboard Space Shuttle Discovery. I've spent a total of 44 days up in space, and during that time, I went around the Earth all the way around 692 times. One of the main components of our Space Shuttle was our giant fuel tank that you see here called the external tank. It's 153 feet long, and it contains 500,000 gallons of fuel that feed the 3 main engines here at the tail of the Space Shuttle. Now, this tank has 2 sections to it. The upper third of that tank contains liquid oxygen fuel. The bottom 2/3 of that orange tank contains liquid hydrogen. And these are what we call cryogenic fuels. And that means they are very, very cold. Liquid oxygen is at minus 297 degrees Fahrenheit, while liquid hydrogen is even colder, minus 423 degrees Fahrenheit. So because of these super cold fuels, that could be a problem for us. I think everybody's familiar with if you have a glass of iced tea or lemonade in the summertime, and because of the humidity in the air in the cold drink, moisture will condense out on the outside of the glass. It looks like water, drops of water are forming there. The same thing will happen with our external tank. Because we have super cold fuel in there, any heat or humidity in Florida is going to cause moisture to condense out on that tank. That moisture that condenses out will immediately turn to ice because of those super cold temperatures. And ice can be a big problem for us during launch. If it breaks off, it can damage the fragile tiles of the Space Shuttle itself. So because of that, this fuel tank is covered with a foam insulation, and we call it polyurethane foam, and it's similar to what you see here. It's about 3 to 4 inches thick, covering the entire external tank. And this is a spray-on foam, so they spray it on, and it takes 3 or 4 hours for it to harden, and then it becomes a very tough structure. But it's this foam insulation that prevents moisture from condensing out on our external tank and then turning to ice that can potentially damage the Space Shuttle. Now, this is a problem for us, and it became a problem on my second mission. 1 week before our scheduled launch aboard Space Shuttle Discovery, a northern flicker woodpecker, like you see here, decided that our giant external fuel tank looked a lot like a big tree. And the woodpecker wanted to build a nest, so it started drilling a hole into the soft foam insulation. It drilled in just 3 or 4 inches, and then it hit the aluminum tank underneath. It couldn't go any further, so it moved over a few feet and drilled another hole. And then another hole, and another hole, and another hole. And this one single woodpecker ended up drilling 205 holes in the soft foam insulation of our external tank. Now, NASA knew they couldn't launch the shuttle like that. Again, these potential holes that we had there were areas where moisture could condense out and turn to ice that could potentially break off and damage the shuttle during a launch. So they had to roll the Space Shuttle back to the vehicle assembly building, where they made the necessary repairs, patched up all the woodpecker holes, and then they moved the shuttle back out to the launch pad, and we successfully launched to space once again on July 13th, 1995. So I can't overstress the importance of insulation. You need to have it covering your entire surface, because any breaks in it are areas where you could have a potential loss of coolant or moisture forming, leading to ice. And for something like the Space Shuttle, that could be very, very hazardous.
Thank you, Don. Now it's time for you to make your own insulation container. Just make sure you don't get attacked by any woodpeckers.